Hey, welcome back to episode 1 of FRC Java programming. Today I'm going to be discussing what subsystems and commands are. I'm going to get right into it. Okay, so you should already have this code base set up. And let's begin with looking at what the drive subsystem class is. And by the way, in Java, all the .java files you see, they're called Java classes. Classes, to summarize, are blueprints of creating their object. So in other words, for example, in drive subsystem, this file defines how the code creates the drive subsystem. So we begin by detailing what a drive subsystem is comprised of. In this case, you can see it's 4 max swerve modules, and then we can see that it's comprised of a gyroscope and some other variables, and then we can see that there's also a swerve drive odometry class that comes into it, and we detail thoroughly about what comprises the subsystem, and then we also define its functionality with methods. And as you can see, these are examples of methods saying public, void, periodic, and then having the parentheses defines. This acts as a method definition declaration. And if whenever we create an object of the type of drive subsystem, we can do the object name dot periodic, because dot periodic is functionality that we define to be part of the drive subsystem. Anyway, that was a refresher of Java as review. So these two files have already been given to us as template code. So if you want, you can for sure look over it. But we're not really going to be messing with this for the purposes of this tutorial. I'm going to actually be making an example intake subsystem.java class. And whenever we do, VS Code does all this boilerplate stuff. And I believe subsystem is actually something you can extend. So yeah, you would have to say it extends subsystem base. Just import that real fast. Extends means that this example intake subsystem class inherits some functionality from the subsystem base, copies the same functionality. So methods we define in subsystem base can be used on any object of type example intake subsystem. Again, if any of these terms sound unfamiliar to you, I recommend you reviewing Java, and object-oriented programming in general, especially concepts of inheritance. We tend to use a lot in programming. So, by the way, these suggestions, they won't be appearing for you. Don't worry about them. They're AI code completions, but it's irrelevant for us right now. All right, so we always have to begin by defining some kind of variables that the subsystem is comprised of. So we can begin by saying private. We can assume that, yeah, we're going to have a spark max. So we're going to have a for the intake motor, and this is going to error quick fix. You have to import the corresponding class. By the way, if I go back, whenever you have an error squiggle, especially for things that shouldn't be erroring out, if you hover over it and then you hit quick fix, it usually gives you suggestions that you should use to do the implementation and fix the issue if it's really simple. And then I guess it's really all we would need for an intake, for example, intake subsystem. And then we would want to define the constructor for it. So we'd say, yeah, public example, sorry about that, public example intake subsystem, and then we'd do that, yep. And then we'd say the parameter that we want to take in when we create the subsystem in some other class is the motor ID for the motor, and then we create the motor. It's fair to assume that we use brushless motors. So whenever creating Spark Max objects, just assume that we're using brushless, unless we're using a different type of motor, which we won't be. And then we want to also define functionality. So we type in public, and then the return type we'd want void in this case to actually run the intake at some power. And then we would say the motor.setPower. Now, this is a complete abstraction of concepts from the drive subsystem. So as you can tell, this is kind of a really complex class, but in the essence of it, it really does 3 basic things. It defines what objects are inside of the subsystem. Then it also defines how to create the subsystem, and then also defines what functionality the subsystem should have. So this is a really, really simple subsystem. It runs the motor effectively. And now we can progress to actually instantiating the example subsystem. So let's go to robotcontainer.java, and As you can see at the very beginning, same format, public class robot container, because everything here is a class. And as you can see here, we see that a robot container is comprised of a drive subsystem, an Xbox controller. So in the syntax here, if you see how we're instantiating it, we're saying private, which is the visibility of the variable. Private means that you can't access this variable from other classes. There's two other types of visibility you can have. You can have a protected variable where objects within the same package can see it, but not but classes outside the package can't. Don't worry about protected. We tend to not use it at all in programming. The other type of visibility you can have is public. However, whenever you instantiate variables that define what a subsystem or a class is comprised of, it's common practice to not use public, but rather have public methods that return private instance variables. The reason for this is because we want to be able to determine exactly how users, or I guess ourselves, are going to be accessing this data in a standardized manner instead of letting the end user decide how to access and modify the variable. And then final says throughout execution, we're using the same object, and mRobot drive doesn't change which object it corresponds to. The code would work fine even if we remove it. It saves RAM on the RoboRio while it's executing. And that's the only reason we add the final keyword. And then we have the object type, which is drive subsystem, and then the variable name. And then we assign it to be new drive subsystem. As you can see, the way we instantiate it is we call it in a very specific manner. So we say drive subsystem here, right? But watch what happens if I type in example intake subsystem equals new example intake subsystem. This is going to be throwing an error, not for that reason, but yeah, we'd say example intake subsystem, and then we'd say intake. Yeah, okay. So now, as you can see, it's going to be throwing two errors. The first error is actually a quick fix one, because we haven't imported the class yet. So we quick fix that. And then here, you can see that it says the constructor is undefined. The reason for this is because if we go back to drive subsystem, we can see that the way that you create a drive subsystem is by saying make a drive subsystem, see? And that's why it doesn't throw an error here, but it does throw an error for us, because if you go back to example intake subsystem, you can see the way we define the constructor is we're asking for whenever we instantiate an object of type example intake subsystem to provide the motor ID. So we actually need to type in any integer inside the parentheses to create it successfully. So 1 would work, 2 would work, that wouldn't work because it's going to be a float because we're doing decimal points. However, we don't tend to usually directly input in the actual number. Instead, we go to constants.java and we assign a variable to be the number in constants, and then reference the variable in robot container. So for example, we would create a class that says public static final class intake constants, and yeah, we say public static final int and then the actual constant. And it's common practice to say k before the actual variable name to indicate that it's a constant. So now what we can do is say constants dot intake constants. Actually, we can say intake constants directly dot k intake motor kennedy, and that'll work. So we successfully created the subsystem, and now what we can do, okay, so that covers the instantiation of it, and then now you're wondering when we're going to use the run intake stuff. So here comes a point where we have to define how we want the functionality to happen. Do we want to explicitly say whenever a button is pressed to execute an action provided by the subsystem itself, all completely unabstracted in robot container, or is there another path? And there is another path, and it's called having a command-based framework where you define functionality of a subsystem, define a subsystem's functionality or a part of a subsystem's functionality in its own class, and define all of the movement the subsystem needs to do there, and then call that set of instructions whenever a button is pressed in robot container. So the process for this is we usually create another directory called commands, and we create a command called intake runner command, default.java. And this command might be deprecated. Yeah. So extends command. Yeah, okay. So you'd have to extend command instead of subsystem because now we're talking about commands now. So sure. This is the default template of a command where, well, excluding instance variables where you define what comprises the command. So you can say the default power is half. And so what you can do here is say that you create the command by passing in a example intake subsystem where, and then let's call it underscore intake. And let's see, subsystem, legal modifier for the constructor in type and private. Oh, there we go. Okay, so we want private final double power instead of default. That was completely on me. Let's get back to it. So now that we have the intake defined as the parameter in the constructor. By the way, the constructor is what determines how to construct the object, how to make it, what components we need to have to make it. And you type it in by saying public because it would be pointless to have a private constructor. So you'd have a public and then you'd do the class name and then you'd have in parentheses whatever parameters you need to take in order to create the subsystem. Create the class subsystem or command. So now what we can say is we also want this, so private final example subsystem m intake, yep. And then we would say this dot m intake equals m intake. This dot here tells Java to consider the m underscore intake variable in this class and not this m underscore intake because they have the same name. So that's how you have to explicitly tell Java to differentiate between the two. You don't need to type in this if they had different names, for example. If I said intakee, for example, then Java would accept that as well. But if we want to have it be the same, you'd have to use this. And it's usually common practice to do a this dot with the parameter and the instance variable being the same name. And then now we come to special methods that the command class gives any command that extends it. Initialize, the code written in initialize runs whenever the command is scheduled to be run. So it runs once at the very beginning. Execute runs every loop cycle. For the purposes of FRC, it's about 3 to 5 milliseconds. It keeps looping through instructions inside execute. The end command runs the series of instructions whenever the command is finished or is interrupted. So if it was interrupted, then the scheduler would call the command.end with true, because for the Boolean interrupted, or false if it naturally ran out. And is finished gives a condition where the scheduler can figure out if the command, if whatever the command needed to do is done, and then it can reallocate resources elsewhere. And as you can see, a way to tell if a method has been inherited and you're modifying an inherited method is if you do the @override. It wouldn't let you do this method if you didn't have @override. Or never mind, sorry. It's common practice to annotate such method declarations with an @override. So what we can also now say here is we can run the intake power with the provided power if at default power, sorry, my bad, default power, or we can actually overload. And okay, now I'm going to talk about overloading constructors, where you can have multiple constructors with different parameters. And the functionality and the reason why you would want to do this is, let's assume that you wanted to make a constructor where you have a default power that you want to do whenever the command is run, but if the user wants a specific power, then you can also support that as well if they provide it. So the way you do that here is, if they also provide beyond the intake subsystem, they also give you a set power to set the motor to, then you can say this dot default power equals power. In this case, I didn't need to. Oh, and then we'd also need to remove final because now we have the option for power to change. And in this case, I don't need to specify this. I can say default power equals power, but I prefer being consistent. So here we would say do, and it would make more sense to leave this as power now because it doesn't make sense to call it default power. So yeah, it'll run that whenever it starts, and then we can say, so at this point now, whenever the command is run, it'll run the intake power at the set power, and it'll keep it at that power even beyond initialize. And this happens because whenever you set power to a motor, it doesn't stop until you specifically state for it to stop. So even though I'm only running the command, the code initialized once, it's going to keep the motor running because whenever you tell a motor to go at a certain power, it'll keep going at the certain power at the specified power until you specifically say stop doing that or running the intake at 0 power. And so and you can have more complicated things here in execute. You can run it so that it gradually increases power. For example, if we wanted to do that, we would do run intake dot run mintake dot run intake at power plus 1 or 0.01, and we'd say that so that every time it'll keep ramping power up. But yeah, things you can do anything once you have a command as well. There's also different types of commands, but I won't get into that because that's somewhat more advanced and it's out of the scope of this tutorial. If we go back, now we can actually make it so that we can tell the program to actually use the command we created. So we can say mintake.setDefault command, and we want to set it to a new intake runner command for mintake. This tells it tells the robot to run the command by default, even no matter what. Whenever the robot is enabled, run the command. In our case, that wouldn't be particularly optimal because it's going to keep ramping up power until it hits maximum. So we want it to not do this. So we want it to do the command whenever the button is pressed or something. So we want to do something a bit more. Whenever we configure button bindings, we can make it so that whenever you can make a new joystick button, sure, we can do write to. And then we can say, while true, we do the command. And this tells the robot whenever the R2 button is pressed, whatever that may be, while it's pressed down, then you will run the intake starting at half power and then ramp it up until it reaches maximum. Now, there's a bug here actually. I realized if we go back to intake runner command, whenever it ends, we have to specify that we want the intake to stop. Because otherwise, even though the command ended, since we didn't give the motor a specific instruction to stop moving, it would keep moving. But yeah, so now we've created a subsystem and a command and interoperability between the two. And we discussed how we can tell the robot container when to run it. Should we run it by default, or should we run it if a button is pressed, or any event really. So hopefully that gives you a better picture of how subsystems and commands can interact with each other. Now, of course, this is a very basic subsystem. This would never be used in production code because usually the subsystems we have are more complex, or we expect more complex behavior. But this gives you a really nice template for what it means to have a subsystem and a command. And hopefully that also, demystifies some parts of FRC programming. All right, thank you.